Hello, sir. Hello, sir.
Hello, sir.
Ah,
Hello, sir.
hello, sir.
I'm audible, sir.
Ah, audible, sir.
Sir, is that audible for you?
Ah, yeah, sir. It's audible, sir.
Okay. Okay, sir. Shall I start, sir?
Ah, yeah, start, sir. You can start.
So, good morning, all. This is Subramanian from Pantech eLearning. I'm project engineer. I'm working here as a project engineer. About Pantech, Pantech Pantech is a product-based and educational institution. We are providing small introduction to Pantech. We are providing microcontroller kits and microprocessor kits, DSP kits, and VLSI, FPGA kit, and power electronics and drivers kits for lab equipments and interfacing cards. We are providing. Uh, After that, Pantech portfolio is about we have started in 2004. We have 4 branches in South India. In Chennai, we have 2 branches and another 2 branches from Bangalore and Hyderabad. In Pantech, 100 plus employees are working, and we have successfully conducted 1200 plus workshops, and with that, more than 8 lakh 50,000 students are gained some knowledge, and we have conducted about 100 plus webinar also. Our portfolio, we are in the industry projects like research and development new products and faculty development programs and hands-on training workshops, internships and in-plant training, and short-term courses, and we are providing value-added courses also, academic projects training like that. In Pantech, we have in Play Store you can see that Pantech e-learning app also. In that you can attend live classes and courses, internships, projects, and products also you can see in that website, and you can also use the app also. Um, in research and development, we have 4 domains. In for electrical and electronic students, we have developed the Internet of Things and artificial intelligence, embedded system and robotics, VLSI, AI, power electronics, electric vehicles. For CSE and IT domains, big data, data analyst, data science and natural language processes, and web development, Android app development, data mining, image mining, text mining, cloud computing, and mobile computing. These are the domains we are providing. Pantech, we are associated with government and central government institutions also. With them help also, we are providing courses, value-added courses and internships. In Pantech eLearning YouTube channel, we have reached almost 7 million views plus, and conducting masterclass regularly. We have subscribers 3 lakh plus subscriber also. This is about Pantech eLearning. Um, we'll start the session by giving the introduction about electric vehicle and what are the history about electric vehicles, and designing of EV, what are the major things we are going to consider, and what are the future technology trends, and what are the research and development areas going on in the EV domain. These are the things we are going to cover today. First, the history of electric vehicles. um, in history of electric vehicles means, many people are some people think that Tesla is the inventor of electric vehicle, like that. But Tesla is the not an inventor of electric vehicle. The first commercial electric vehicle that was invented in the year of 1819, his name was William Morris. From there many people tried to make EVs, but the one thing that was very challenging, that was battery pack. In 1890, the battery pack was very huge in size, and weight also it's very huge. That time the charging time also 10 to 12 hours we are charging, and it will give the range about 20 to 30 kilometers only. Because of the drawbacks in that 1890s, the EVs are fading. After that invention of Tesla, they are invented the efficient way to use the battery, which will consume very less space and have more stability. With that only the electric vehicle industry boom have been started. Uh, After that Tesla invention, from there it's a really big boom for EV industry. Many vehicle manufacturers started to manufacture their own four-wheelers, two-wheelers, scooters, like that. They were started in 19th century early. In urban areas, electric vehicles are more popular in 90s, but at that time, the petroleum vehicles have been introduced. That was Model T, that was introduced in that year of 1908. That vehicle cost around $560. At that time EV sold for $1,750. Because of the cost consideration and the time petroleum becomes cheaper and the national road system improved, and internal combustion engines are dominated the electric vehicle at the time of, because of the cost consideration. After that 1970s, fuel shortage create the interest in EVs again, and many government policies and incentives are excited to the people to buy electric vehicles. And some new European driving cycle standard, that was the worldwide standard. They have introduced the carbon dioxide emission, that was a very huge problem in climate changing. They are introducing the carbon dioxide emission in early 90s onwards. That act, called name as the Energy Policy Act, has passed with the new requirements on carbon dioxide emission. This is about history of electric vehicles. We'll start in about electric vehicle, small introduction. Nowadays, what are the things we are having in electric vehicles? The thing about electric vehicle is the function of electric vehicle is one or more than one motors being powered by the battery pack. That electric vehicle is which are partially or fully powered by batteries. And electric vehicles, they are eco-friendly, and the advantages about electric vehicles are less moving parts when compared to the IC engine. IC engine is nothing but the internal combustion engine. That was a conventional vehicle in long days. The automobile industry started in the year of 1890. The in internal combustion engine, there was a lots of moving parts compared to electric vehicles, in that we have only certain number of moving parts only. Because of that, low maintenance and low running cost, and there is no burning fuel in electric vehicles. In electric vehicle we can get instant power deliver and high torque application we can use with with that instant torque. That in electric vehicle is a single gear transmission only is there, compared to IC engine. IC engine multi gear transmission, you people may have seen that. With that single gear transmission, we can efficiently run the vehicle, and there is no that much maintenance cost compared to the internal combustion engine. um, this is the block diagram of electric vehicle. In that the energy source is nothing but a battery pack. The battery pack is giving to the power to the motor. The battery is nature of the battery is the converting the electrical energy chemical energy into electrical energy. The battery also providing the power to the external accessories like lights and AC system. They are providing. In between the motor, electronic power converter is there. The electronic power converter is the one of the topic in major topic in research and development areas. If you are going to that electronic power converter means is a it's related to power electronics. You people may studied power electronics subject in college days. The power converter, in power converter variety types of converters is there. Depending upon some motor we are used in the vehicle, depends upon the motor, we should develop a power converter for the vehicle. The vehicle controller here is nothing but a motor controller. If you are giving the signal to the if you are applying a brake or accelerator, that signal is going to be the control the motor by taking the action by the vehicle controller only. Energy management system. The energy management system is like battery management system. How you can utilize, you are going to utilize the battery to the electric vehicle in very efficient manner. Energy refueling unit is nothing but a charge port in electric vehicle. It's in this energy refueling unit, you can charge the electric vehicle whenever the battery drains. The hotel climate control unit is nothing but a CAN bus. The CAN bus is a communication protocol that was invented by the Bosch company. In the block diagram you can see that electrical propulsion system and auxiliary subsystem and energy source subsystem. In that block diagram we have separately in three division. One is the electric propulsion subsystem, auxiliary subsystem, energy source subsystem. This is the overall main components of the electric vehicle. In that, electric traction motor, traction battery pack, power electronics converter, DC-DC converter, charging port and thermal system, and auxiliary battery and onboard charger. Electric traction motor is nothing but if you are going to see talk about electric motor means in that different types of motors is there. In electric vehicles, most of the electric vehicles, they are in early stages they are used as brushless DC motors in most of the electric vehicles. After that, the invention of power electronics devices, we can use the AC motors also in electric vehicles. Types of electric vehicles. In that, nowadays we are using mostly three types of electric vehicles, that was battery electric vehicles and plug-in hybrid electric vehicle and hybrid electric vehicle. Fuel cell electric vehicles are now also developing, and India some cars like Toyota Mira is used as a fuel cell electric vehicle. The first battery electric vehicle, this is about battery electric vehicle. In battery electric vehicle, the main fuel source is electricity, and battery travel with a long distance and powered by electric motor. This is the block diagram of the battery electric vehicle. In that battery, power converter, motor and transmission, these are the basic components in battery electric vehicle. The next one is the plug-in hybrid electric vehicle. In plug-in hybrid electric vehicle, we can use internal combustion engine and battery pack. The battery pack in plug-in hybrid electric vehicles somewhat reduced in the size of compared to the battery electric vehicle. In that we can use fuel sources as electricity and gas. Battery travel is a medium distance only it can travel. After that we can use the internal combustion engine also. Next one is a hybrid electric vehicle. Hybrid electric vehicle is a combination of internal combustion engine and electric vehicle. In that fuel sources, main sources like gas or petrol, diesel we are using. The battery range is here as a short distance only. The main component in hybrid electric vehicle is the internal combustion engine. In that hybrid electric vehicle, we have different types of hybrid electric vehicles. One is a series hybrid electric vehicle. In that we can use the motor to drive the vehicle. The generator is used because to charge the motor, to charge the battery with the help of IC engine, that is powered by the fuel tank. Series hybrid vehicle is only in this motor only powered the vehicle. IC engine is only used for the purpose of charging the battery only. In parallel hybrid electric vehicle, here we can use both IC engine and motor to power the vehicle separately. If you are interested in IC engine, you can switch it to the IC engine, or you can switch it to the motor to drive the vehicle. This is a good parallel hybrid electric vehicle. Today's topic about EV design and technology strengths. If you are going to develop electric vehicles, means the basic three things we have to consider. That one thing that was propulsion power, motor size and battery capacity. These are the basic thing we have to first develop. What are the powers required to the motor, and propulsion power and motor size and battery capacity that was needed to run the vehicle in certain range. In propulsion power, the main thing about we have to give the total tractive force. The total tractive force is nothing but a amount of force required to overcome the frictional resistance when two bodies slide or roll on each other. In that electric vehicle, is there four forces acting on a vehicle. We have to consider these four forces. That first one is the rolling resistance force, and next one is the aerodynamic drag force and hill climbing force and acceleration force. In acceleration force, linear acceleration force and angular acceleration force. First we will see about the rolling resistance force. It is one of the force that act to oppose the motion of the vehicle. The coefficient is a function of the tire material, structure, temperature, pressure, tread geometry, road roughness, material presence and absence of liquid on the road. These are the thing we have to consider in rolling resistance force. Depends upon the nature of the road. We are having the rolling resistance coefficient, constant coefficient for each type of roads. For example, car tires on concrete asphalt, we are using a constant about 0.013. Car tire on rolled gravel, 0.02. Tar macadam, we are using 0.025. Unpaved road, 0.05. Field road, 0.12, 0.35. These are the constant value we are going to take as a rolling resistance force. For rolling resistance force, the formula to calculate is mu r mg. Here mu r is the rolling resistance constant, m is the mass of the vehicle, g is the gravitational acceleration constant. The rolling resistance force, it will be vary, depends upon the speed and the pressure of the tire also. Total power required for the electric to drive the electric vehicle. Its formula is total tractive force into the velocity. The total tractive power, that this is the summation of the rolling resistance force and aerodynamic force, hill climbing force, and linear acceleration and angular acceleration force. These are the formulas for the rolling resistance force and the aerodynamic force, drag force, and linear acceleration force, angular acceleration force. This is one of the example for EV rating. If you are considering two-wheeler, means the weight about 1000 kg and width of the vehicle is 1 meter and height of the vehicle is 1.50 meter. The rolling resistance constant we are here taken as a 0.02. Air density is 1.25 kilogram and meter square. Drag coefficient is about 0.30. Gravitational force is about 9.80. With this parameters, we can develop a total tractive force. In that parameters, we have developed 40 kilometer per hour speed. For it will require velocity about 11.11 meter second. The total tractive force is about 40 kilowatt, means we can convert into the battery pack with the help of the tractive force required is a 170.15 Newton meter for the 40 kilometer speed range. For that power we have calculated is a 1890 kilowatt power is required to run the vehicle at the speed of 40 kilometer. The total tractive force, as I mentioned, 170 Newton meter is calculated with the help of this formulas. With these formulas, the power required for the 40 kilometer is 1.8 kilowatt power is required to run the vehicle. What are the motors we are using in electric vehicles? Mean DC motor, AC induction motor, and permanent magnet brushless DC motor, and permanent magnet synchronous motor, and switched reluctance motor. These are the motors we are using in electric vehicles, most of the vehicle. This is are the first one is a hub motor. This is normally used in the scooters and two-wheelers application. These are in motors mounting also it will differ based upon the vehicle architecture. uh, it's depends upon the single drive, it's about single drive system and dual drive system. In rear wheel we have two motors to for each tire. This is all wheel drive system. In this system each four wheel having a separate motor for to power the vehicle. Battery for EV application. The types of batteries we are using is the primary and rechargeable and non-rechargeable batteries. And primary battery is non-rechargeable battery, and secondary battery is rechargeable batteries. Types of EV batteries are lithium-ion batteries and lithium phosphate and nickel metal hydride batteries. Um, Now, in that EV design, the battery configuration is one of the main thing. Uh, in that battery configuration, you people know that is a series combination, parallel combination, series parallel combination. These are the configuration is required to develop the battery pack for that EV. For the required power, it have to develop. For parallel configuration, you people know that in parallel combination the voltage will be same in that. If you are considering this example, in that we have included four lithium ion battery cell to load the here this load is nothing but a the vehicle have to move. In that we are using 1.5 volt batteries, four batteries we are connected in parallel connection with that 2000 milliampere hour current it will produce each battery. In parallel connection 1.5 volt uh, is giving to the load, and the current rating is 8000 milliampere. In series parallel connection we have included the two batteries in series and two batteries in parallel combination. With this we can give the load about 3 volt and 4000 milliampere current to the load. In observation of battery, if you are having a battery rating of 72 volt and 166.67 ampere hour battery, this can develop the power of about 12 kilowatt. People know that the power formula is V into I only. That 72 volt into 166.67 ampere hour is a power rating about 12 kilowatt. With this 12 kilowatt battery we can give the power to the motor. According to the speed of the vehicle, the battery will give the power. If we are running the vehicle at 40 kilometer hour, we need a 1890 kilowatt power from the battery pack. If it's that 50 kilometer per hour means we need a 2544 kilowatt watt battery pack. And in 100 kilometer per hour means we need to give the power along 8 kilowatt from the battery. The battery rating is about 12 kilowatt means we can run the vehicle about the speed of 100 kilometer per hour in 1 hour. We can run the vehicle with the help of 12 kilowatt battery. The the balance 20 percentage it will be it should not be drained, because the lithium ion batteries are have a nominal voltage like 3.7 voltage is the maximum voltage and 3.4 voltage is the minimum voltage. In between we have to charge and discharge the battery. Okay. In that observation we have neglected the hill climbing and angular forces are not considered. The vehicle will cover 100 km and balance 20 km energy will be available. This is about battery assemble. Lithium in most of the electric vehicles we are using lithium ion batteries only. Lithium ion batteries is our series and parallel connection of cells. We are developing the battery pack. This is a single battery cell. This is a battery module connected, and we are going to develop series and parallel combination to the required power. So that is the battery module. In series, after that battery module we have converted into battery pack. This is the total battery pack of the electric vehicle. This is a block diagram about battery, how it is performed. In battery we have to charge and discharge. That's why we need here as a bidirectional DC-DC converter. With the help of bidirectional DC-DC converter we can develop we can charge from the grid whenever the battery is drained, and at the same time we can give the power to the load with the help of bidirectional DC-DC converter. Next, technology trends in electric vehicle. What are the technologies that was trending in nowadays? We are going to see one by one. The first thing about technology trends means range extension is the one of the trending technology in battery electric vehicles. The advances in battery technology have been extended the range of electric vehicles. Higher energy density batteries are allowing EVs to travel longer distance on single charge. This increased range that can be addressing one of the primary concern of the potential buyers to buy the electric vehicles. In this slide we have mentioned that ranges of all electric vehicles. This is about a lucid air electric vehicle having a 516 miles for a single charge. This is the top of the electric vehicle industry. They are developing in recent days. Mercedes is having a 452 miles. Fisker Ocean is 450 miles. Polestar is having a 406 miles per single charge. Tesla Model S is having a about 400 miles, and Tesla Model 3 having a 391 miles, and BMW i7 having a about 387 miles for a single charge. And this is one of the trending technology in range extension. Now the range extension is one of the technology, as I mentioned, in that the battery is the main component we need to consider. In battery I have mentioned that lithium ion battery is used worldwide for the electric vehicles. The recent trending was solid state batteries. They are developed in some countries. That is going to be the one major thing in electric vehicle industry. After the invention of solid state solid state batteries, the range about we can increase the range extension on about 850 to 950 miles per single charge. The next technology is about fast charging infrastructure. In electric vehicle we have three levels of charging stations. One is AC charging station, another one is the AC level 2 charging station, and a DC fast charging station. In that AC level 1 charging station, the voltage levels up to 120 volt. There was single phase AC charging system. The current rating about 12 to 16 amperes. It can charging the load about 1.4 to 1 kilowatt load. The charging hour will be 3 to 5 miles for range per hour. 3 to 5 hours it will take to full charge the vehicle. In level 2 charger, the voltage will be increased about 208 volt or 240 voltage, and single phase. This is also single phase system. In that current rating will be 12 to 18 ampere. 18 ampere. Charging loads up to 2.5 kilowatt to 19.2 kilowatt. Typically 7 kilowatt charging stations are uh, most popular. In that level 2 charger, we can charge the battery electric vehicle within uh, 2 to 3 hours, 10 to 20 miles of range per hour. Like that we have to charge. In that DC fast charging, the voltage range is increasing about 480 volt, and here that was 3-phase AC system. The ampere in current rating is 125, greater than 125 amperes we are using. Charging loads greater than 90 kilowatt. Typically 50 kilowatt charging stations are more popular in nowadays. In that 0 to 80 percentage of charge we can achieve in 20 to 30 minutes only. DC fast charging, the cost wise it was more cost compared to level 1 and level 2 chargers. With the help of DC fast charging, we can easily charge the vehicle within 20 to 30 minutes. Fast charging is infrastructure is one of the trending technology nowadays. um, DC fast charging also they are going to develop the charging infrastructure like 10 to 20 minutes charging time. For that, the voltage range will be increased up to 480 voltage, greater than 480 voltage it will come. The DC fast charging, in that grid we are having a 3-phase alternating current. We need to convert that into DC direct current. For that, power electronics converter we are using. With that we can increase the voltage range also, voltage range and current range. With that help, DC fast charging, 10 to 20 minutes we can charge the vehicle about 80%. Next one is the battery technology. one of the One of the most promising innovation in electric vehicle battery technology is the development of solid state batteries. As I mentioned, these batteries use solid electrolyte instead of liquid or gel based electrolytes. In lithium ion battery, in the electrodes like liquid or gel based electrolytes, but in the solid state batteries there is no like that liquid and gel type of electrolyte. With that solid state batteries we can charge the battery in 10 to 20 minutes, and the range also going to be increased. Research into next generation battery chemistry means that only about solid state batteries only. uh, Solid state battery is one of the most battery in development industries. Also lithium sulfur battery and improved lithium ion batteries and has been ongoing in the research and development areas. This technology promises the higher energy density, faster charging, longer lifespan, and improved safety. This is about battery technologies. Next one is the electric SUVs and trucks. EVs are no longer limited to compact cars. Automakers have been focusing on developing electric SUVs and pickup trucks to meet consumer demand for larger and more versatile vehicles. Uh, the one of the SUVs we have know as a Jaguar I-Face, that was introduced in the 2023 July. The battery pack of Chakwar I-Phase is about 90 kilowatt hour and a lithium ion battery pack, two electric motors, one at each axle, which produce a total of power of about 3094 horsepower. This result in SUV that can hit 60 mile per hour in less than 5 seconds. Okay, the top electric SUVs manufacturing in India worldwide is Tesla, BMW, and Rivian, Lucid Motors, and Nissan, and BYD. It's a China-based company, BYD. And top electric truck manufacturers are Ford, Rivian, General Motors, Stellantis, and Tesla. These are the top electric truck manufacturers in the worldwide. Next technology is about advanced driver assistance system, that was ADAS. um, EVs often come equipped with advanced driver assistance system including adaptive cruise control, land departure warning, and parking assistant, hazards recognition, blind spot detection, adaptive cruise control, fatigue warning. These features enhance safety and convenience to the vehicle owners. Uh, with that help of adaptive cruise control and parking assistance system, this features is very helpful to the vehicle owners to drive the electric vehicles. Next one is a vehicle to grid technology. In vehicle to grid technology is a smart and innovative approach that enables electric vehicles to interact with the electric grid, serving as both energy consumers and energy resources. Vehicle to grid allows electric vehicles to not only charge from the grid but also discharge stored energy back into the grid when needed. This bidirectional energy flow turns EVs into mobile energy storage units. We can use the electric vehicle whenever we need a power like the power cut duration. We can give the power from the electric vehicle to household applications. In vehicle to grid, uh, we can charge the vehicle from grid, and whenever the grid demands more power, that time we can give the power to the grid. This is about vehicle to grid technology. This is one example we have developed for electric vehicle. In that we have 37 voltage battery pack. It's a combination of series combination of 10 lithium ion cells to we get 37 voltage battery pack. This is about DC motor control. This is a DC motor from the MATLAB simulation. This is the motor control unit. We are measuring the voltage from the battery pack, and we are giving the signal to the control voltage source, and we have developed the control system here. With adjusting this constant value, we can increase or decrease the speed of the motor. If I giving a 0.5 as a constant value, yeah, I am going to run the program. In that we are getting with the zero point 0.5 constant, we are getting our speed about 100 rpm of the DC motor. If we are changing the constant value about 1, with the help of constant value we can vary the speed of the motor. Different kinds of control algorithm we can develop with the help of MATLAB simulation. In that time, with the constant value 1, we have developed about 200 rpm for the DC motor. The speed will be 200 rpm. Thank you, students. This is about electric vehicle design and technology trends. Guys, in that you are having any doubt, you can mention in that comment box.
Hello. Yes.
Sir. Student, if there any doubt means you can post in comment box. I can give a solution to it.
Guys, just 2 minutes wait. We will posting the attendance link in live chat, or otherwise in the else just forward the attendance link to yours.
Hello, sir.
Sir, we'll share the attendance links.
ஓகேங்க சார். சார் ஏதோ நீங்க லிங்க் இருக்குன்னு நீங்க ஃபீட்பேக் ஃபார்ம் லிங்க் இருக்குன்னு சொன்னீங்க. அத குடுத்து நான் குரூப்ல ஃபில் பண்ண சொல்லி சொல்லிடுறேன்.
Okay, sir. I'll share, sir.
ஓகேங்க சார். அத நீங்க அட்டெண்டன்ஸா கன்சிடர் பண்ணிக்கோங்க.
Okay, sir.
தேங்க் யூ சார்.
Thank you.
சார் தேங்க் யூ சோ மச் சார்.
Thank you, sir. Okay, sir.
எங்களோட சொல்லு.
Okay, guys, thank you. We will post the Google Meet link through this SAR, and we will posting the live chat in Google Meet attendance form link.